Hypothesis testing two population case. In this we want to compare whether the parameters originating from two populations are same or not. To do that comparison, what we do is we draw a sample from each of the population and compute the sample statistic. By looking at the values of the sample statistic, we want to infer whether the population parameter of the two populations is same or different. For example, we may want to compare two metropolitan cities, let's say Toronto and New York, and we want to determine whether the population parameters of Toronto and New York are same or different. For that, we will take the sample from each of the cities, compute the sample statistic, and with the 95% confidence and build confidence interval built around the sample statistic, we determine whether the two populations are same or different. Oftentimes, we may be provided with two samples, and we may be asked whether these two samples originate from the same population or two different populations. Now, whether the same population means the same set of subjects or the two populations exhibiting similar behavior. So we will talk about comparing the means and the proportions. We will start with the means. Within means we have two scenarios. One, that the samples are independent or samples are dependent on each other. We'll start with the independent samples. By independent samples, we mean that the members of each of the samples are completely different. We have two scenarios again, whether we know the population standard deviations or we do not know the population standard deviations. In case we know the population standard deviations, we use the formula z equal to sample 1 mean minus sample 2 mean minus population 1 mean and the population 2 mean difference, which are our hypothesized means, and divide by the standard error formula, which is shown here. Now we look at a scenario when we do not know the values of the population standard deviations. In that case, we will use the t-test. We may not necessarily know the population variances, but we will have to make assumption about the nature of this population standard deviations. We have two scenarios, that these two samples are originating from the populations which have same variance or same population standard deviation. So in this case, we will use this formula with the degrees of freedoms given by n1 plus n2 minus 2. When the population standard deviation is unknown, but we know that the population standard deviations are not equal. When they are not equal, we use this formula. The degrees of freedom in such a scenario will be fractional. Sometimes, from practical point of view, instead of using this formula to compute the complicated degrees of freedom, we may assume the minimum of n1 minus 1 and n2 minus 1 as the degrees of freedom. That's a common practice. Now let's extend the hypothesis testing to two population case where the samples are dependent or paired. In that case, what we do is we take the pairwise difference, and once we get the pairwise difference, we use the difference as a random variable of a single population. We use this typically in case when we want to test the effect of a certain treatment or certain conditioning. For example, we may test the knowledge of students about data analysis before they enroll into a course. Then they undergo a course. After that, we again check the knowledge of data analysis, and we may want to compare whether that course is effective or not. We may want to try this with the medicines. We may try it with the diagnostic testing. For example, we may want to know the fasting sugar level and the non-fasting sugar level and compare the difference in the change in the sugar levels or the sugar spikes. So we use the t-test here for comparing the differences. It is similar to our single population parameter hypothesis testing. Let's talk about comparing the proportions. In that case, we have hypothesis which is looking at the difference between the two populations, whether they are same or different. Again, we have two different scenarios here, that we know the population proportions. When we know the population proportions, we use the Z formula given by this formula. When the population proportions are unknown, we use the estimate or the weighted estimate from N1 and N from sample 1 and sample 2 with the weights N1 and N2, and then we use this formula for computing our test statistics. And rest of the steps for computing the test statistics and performing the hypothesis testing is same as the single population case.